So let's solve this following differential equation. We begin by rewriting it as dy over dx. So that will be equals to x cubed minus 3xy squared divided by y cubed minus 3x squared times y. Now this is a homogeneous differential equation. The reason behind this is if we consider the expression in the numerator. So let's say this is denoted by f, a function of x comma y. So if we substitute the value of x with lambda times x and y with lambda times y, then you can substitute x with lambda x and y with lambda y. What do we see? We obtain lambda cubed times f of x comma y. Similarly, if we do that for g of x comma y, which is given by the function in the denominator y cubed minus 3x squared y, and if we substitute g of x with lambda x and y with lambda y, then we'll also obtain lambda cubed times g x comma y. So this means that both the two functions f and g are homogeneous function with degree 3. Now since f and g are both homogeneous, so f over g, that's also going to be homogeneous. So that means we have a homogeneous function on the right hand side. So that means dy over dx equals to this particular expression represents a homogeneous differential equation of degree 3. Fine. So how do we solve this type of differential equation? All we have to do is replace y with vx. And what we can do, we can differentiate both sides with respect to x. So that will give us dy over dx. So that will be equals to v plus x times dv over dx. So this means our differential equation can be now rewritten as v plus x times dv over dx. So this will be equals to x cubed minus 3x. So in place of y, we have vx squared, all divided by, so in the denominator we have y cubed, so that will be vx whole cubed minus 3x squared times y. So y will be v times x. So what we can do, we can take x cubed as the common factor from both the numerator and the denominator, and this will reduce to the next step. We'll take the v from the left hand side to the right hand side. So we can subtract v from both sides, and then we'll combine these two terms. So that should give us 1 minus v raised to the power of 4 whole thing divided by v cubed minus 3v. Now we can separate the differentials, and this should be v cubed minus 3v whole divided by 1 minus v raised to the power of 4 times dv equals to dx over x. So this is now in the separable form. So that means we can integrate both sides. So let's perform the integration. So we will have v cubed over 1 minus v raised to the power of 4 dv minus 3 times integration of v dv divided by 1 minus v raised to the power of 4 can be also written as v squared whole squared. This will be equals to integration of dx over x. Right. So we'll start by integrating each of the two integrals. So let's consider this as I1 and this is I2. So I2. So let's perform each of the integral one by one. This is a very simple integral. This can be performed, the integration can be performed by using the method of substitution. So here we are going to suppose that 1 minus v raised to the power of 4, let this be equals to the variable u. Now differentiating both sides with respect to v, so that is going to give us negative 4 times v cubed times dv. So this will be equals to du. So our integral now becomes negative 1 over 4 times integral. So we have v cubed dv, so that will be replaced with du divided by u. So we know integration of du over u, so that's simply natural log of u. So u here is 1 minus v raised to the power of 4 plus the constant of integration but I'm not going to use the constant of integration here. That will be taken care of with one final constant of integration at the end. Now let's come to the second integral. So our second integral is given by integration v dv divided by 1 minus v squared whole square. So here we're going to make the substitution. So let's say v squared equals to t. So differentiating both sides will give us v dv, that will be equals to half dt, such that our integration converts to half. So we have dt divided by 1 minus t squared. So this one can be also written as 1 squared. The reason behind this is we are going to use the formula that integration of dx divided by a squared minus x squared. So this is simply equals to 1 over 2a times natural log of a plus x divided by a minus x plus the constant of integration c. Now in our case, the value of a is 1 and x, the variable, is simply t. So that means we should get half multiplied to 1 over 2a. So I is 1 times natural log of a plus x. So that means 1 plus t divided by 1 minus t plus some constant of integration, but that will be taken care of. So we have 1 over 4 times natural log of 1 plus t, but t is v squared divided by 1 minus v squared. Now that we have the values of y1 and y2, so let's substitute this back into our original equation. So we have negative 1 over 4 times natural log of 1 minus v raised to the power of 4 minus 3 over 4 times natural log of 1 plus v squared divided by 1 minus v squared equals to, so we have integration of dx over x, so that will be natural log of x plus the constant of integration, which will be the sum of the constants from all the three integrals. And since everything is written in terms of logarithm, so we'll consider the constant to be in the form of logarithm. So let's take log of c. Fine. Now the next thing will be to do is to combine the terms and get rid of the logarithm. So let's do that. This is the solution, but we want a much simpler version. So we'll do it step by step. So let's multiply both sides with negative 4. So this will give us, we have natural log of 1 minus v. So we can also replace v with y over x. So we have y raised to the power of 4 divided by x raised to the power of 4. Positive 3 times natural log of 1 plus, so we have v squared, so that will become y squared over x squared, whole divided by 1 minus y squared over x squared, and that's equals to negative 4 times natural log of x, negative 4 natural log of c. So we have natural log of x raised to the power of 4 minus y raised to the power of 4 divided by x raised to the power of 4 plus 3 times natural log of x squared plus y squared divided by x squared minus y squared equals to negative 4 natural log of x plus 4 times natural log of c. We can take this 4, so we'll rewrite it as c raised to the power of negative 4. Now we'll use the property to separate the two logarithms. So we have natural log of x raised to the power of 4 minus y raised to the power of 4 minus log of x raised to the power of 4 plus 3 times natural log of x squared plus y squared minus 3 times, let's keep it as it is, we're not going to break it down, equals to negative, so we'll take the 4 and raise it to the power of x. So we have negative log of x raised to the power of 4 plus log of c raised to the power of negative 4. So this logarithm and this logarithm goes away, And then we have natural log of x raised to the power of 4 minus y raised to the power of 4 plus, so we'll take the 3 and raise it as the power. So we have log of x squared plus y squared divided by x squared minus y squared whole raised to the power of 3. And this will be equals to log of c raised to the power of negative 4. So let's call this a, where a is equals to c raised to the power of negative 4. Then we can combine these two logarithms. So we have natural log of x raised to the power of 4 minus y raised to the power of 4 multiplied to x squared plus y squared whole raised to the power of 3 divided by x squared minus y squared raised to the power of 3. This is equals to log of a. Now we can get rid of the logarithm from both sides. And also we have x raised to the power of 4 minus y raised to the power of 4. So we can rewrite this as x squared minus y squared multiplied to x squared plus y squared times x squared plus y squared whole raised to the power of 3 divided by x squared minus y squared raised to the power of 3. So this is equals to a. Now we'll see immediately that few of the terms get cancelled out. So this will get cancelled out and one term from the denominator. So there will be a square here. And in the numerator, we have x squared plus y squared raised to the power of 4 divided by x squared minus y squared whole raised to the power of 2 equals to a. Or simply x squared plus y squared whole raised to the power of 4 equals to a times x squared minus y squared whole squared. And what we can do, we can take the square root on both sides. That will give us x squared plus y squared whole squared equals to b times x squared minus y squared, where we have considered the constant b equals to square root of a. So this is the required solution to a given differential equation.